Hello, my name is Shane in Sweden and welcome back to our series of videos on how to build an intrusion detection system using C# and Visual Studio. And as always, if you want to follow along with the coding, the practical examples we're looking at in this video, you'll find a link to the source code as it is right here under in the notes. So feel free to download it and follow along and code with the video. Okay. In the last episode, we looked at extracting IP address information and port numbers from network packets. And in this video, we're going to look at another aspect. So far, we've been working almost entirely with the sensor. Now we're going to look at the reporting side. So as always, we are going to work on a test, and we shall create some new tests here. And our new class we will call report tests. And this is, of course, a test class. And let's add a new method for our test simple reporter. Reports successfully. And this will be a test method. Okay, so initially we're going to create a reporter, and this will be a new interface we have. It's called an iReport agent. And at the moment we're just going to substitute for that using this end subject. And this doesn't exist, so we'll have to create it. And here we might have a method report packet captured. And there we would have perhaps a .NET packet. And of course, we would perhaps want to know the time the packet's been received. So and perhaps from which sensor it came, so sensor ID. Let's just use that as a GUID. Sensor ID. Okay, so we've got that method in our interface. And so when we capture an interesting packet and we want to report that information, we can call this method the packet, and of course when it was captured and which unit captured it. So in our sharp pcap test here, we created a test capture device which automatically generates a packet capture. And we can use this again here to test our reporting. So we're creating network information source. And then we're going to create a sensor. And now we're going to pass our network information source to that. And we need to create a rule, I think, for this, a simple rule. And then here we need a string pattern. Now our test capture device contains a packet of data which we captured from Wireshark, and here we can see this is the text in it. So if we set our rule to capture FTP, we should be able to get some response. So we'll create our simple rule with the text FTP. We'll pass that into our sensor. Now, reporting units are one of the things that are like the rules. There's something that will change a lot. So we want to be able to adapt in the future and use different types of reporting. We may have a reporting agent which, for example, writes to an Azure cloud device, or perhaps it writes to a local file or a network file or a database. We need to be very flexible. So again, it's useful here to use the strategy pattern to inject different types of reporters into our sensors when we create them, so that in the future, if we add a new type of reporter, we can also use that with a sensor package without actually having to change the sensor code. So we're going to send in our report agent. And then we're going to turn on the sensor, start to listen. And then we want to assert that we've actually carried out a report. We want to check that the reporter actually reported the packet capture. So we can use the endsubstitute extension method here. So we can take our report agent and we can use the received with any arguments. We don't really care what arguments came in when the reporter agent reported. We just want to check that it actually called its method. So we can send a null for the moment and date time now, and a new grid, whatever grid.empty, right? So we've got a few things to build here before this actually starts to work. First, we need to generate a new constructor, and we also need to add a new start method. So we've got a new constructor here which has an iReport agent. We should move our iReport agent interface to where all the other interfaces exist. And we just need to change the namespace and delete it from here. So if we go to our sensor now, we have an iReport agent parameter coming in the constructor. So if we go back to our report test now, we need to do something about start method. In the start method, we really want to call our information source and tell it to start. So the question is, what do we actually want to start here? We're planning on using several different types of information sources. Now obviously when we've got a sharp PCAP capturing device which can capture data directly from the network, in that case we actually do want to start it. But in the case where information source is a web server log file, there's nothing really there to start. A log file actually will grow and the web server will append more information to it as it goes along. So we do need to keep checking the log file to see if there is any new data in it, but we don't actually really need to start it. So we've got a method here which isn't really applicable to all our information sources, but we do want to use it for our information sources that we can control. I guess you would call active information sources. So we have passive information sources like a flat file, and we have active information sources like a network capturing device, and we'll have to differentiate between them in some way. So let's create a start list listing for our network information source if it is an active device. So, but that method doesn't exist, so let's create that. Now, as we said, the iNetwork traffic information source, this interface applies to both static or passive information sources like a flat file, as well as an active information source. So we may want to extend we may want to create a new interface here for active devices. Now, if we add active or passive here, it's going to start getting very long, so it might be time to actually refactor and rename this to something more simple, such as information source. So let's use the power of resharper there. And now we can create a new interface called iActive information source. Which inherits from iInformation source. And this will have the start listing method and stop listening method. So I'm back in our sensor now. When we start listening, we want this method to apply for active information sources only. So we can go to our sharp PCAP information source, which actually inherits from simple information source, but we want it to also implement active information source. So we already had a method which is called start listening, which did actually start the capture for our capture device from the sharp PCAP iCapture device interface, and so we can do the same for stop listening. Now if we go back to our sensor, obviously we only want this to apply when we have an active information source, so we can perhaps use a dynamic method here. Okay, and we'll just create the method. And we'll have two different. We'll have, if we've got an active information source, information source as dynamic, and then depending on if it's an active information source, we would want to start. And if it's just an ordinary information source, we don't do anything for the moment. There may be separate things we wish to do when it's a passive source as well. Okay, so for our active and passive information sources, they have their separate initialization, and then we want to process the messages that both sources contain. Now, an active source may capture data, so periodically there will be new information, and even a static or a passive information source such as a log file will be written to occasionally by the web server. So again, we have to check occasionally if there's information. It would be nice to have some sort of mechanism that works for all of our information sources. So one mechanism we can use is just to periodically check and see if there's new information. Now this type of operation is a standard operation in systems, which is called polling. Now in .NET and C# there are many ways to implement polling using timers, and there are several timers, or you can use background workers and threads. In this case we're going to use another method called tasks. So we're going to create a new task that will periodically poll our information source and try to process the next message. We're going to create a listener or set a listener going. And then inside our polling, we can set an infinite loop at the moment. Here we're going to do stuff, and that stuff would be and then we let the thread sleep. For a delay. And we'll set a private read only on that. And for the moment in our base sensor we'll just set a delay for 1000. What happens when we start our sensor It'll initialize the information sources, passive or active. It will start polling the information source to process the next message, and any messages will then be processed. So this is basically what we were talking about in a much earlier video when we said we would just want to start our sensor and let it keep running and processing messages as they come in. Actually, I'm just noticing something here. We send in the information source with a capital I, which is here, the public, which will just immediately throw an exception, and this should actually be return. And I'm not sure we actually need a set for the moment, so we can leave that as it is. So when we start our sensor, it initializes its information sources and starts polling them, trying to process the next message until it stops. But at the moment we haven't implemented that bit, it'll just actually keep polling forever. Actually, something else I've just noticed also is that we moved our simple information source, but we didn't delete the old copy. It's still here, so let's just get rid of that. And let's just build our solution, check that everything's okay. So now we can perhaps go to our report tests and see if we can run it. We're getting a failure. So let's just check that, see what the problem is. Okay, the problem here is that this event is thrown even though there's nobody actually listened to the event just at this particular moment. So we should actually stop that and have a control where we only call the event if somebody's listened to it. So, and we can run our select test again. Okay, we've got a failure on our test. And if we look at the reason why, we can see we expected to receive a call matching the report packet captured, and it didn't. So basically we didn't call a port method. So we need to look at why that happens. If we go to our sensor, it starts whenever it goes in, every now and again process the next message. When it comes in to process the next message, it will fetch the message and it returns whether or not the rule matched. So this is actually not what we want to be doing anymore. When we get a rule match, we want to report. So let's do if rule match message. Then we need to call the report agent. And here we want the packet, the time, and the date source, which we don't have here at the moment. So let's try get the test to work. Okay, and then we can return. Okay, so we can run our test again. And we're still getting a failure. Okay, well we can see that we still have the problem here. We're actually not calling the report packet captured method at any point, and so our test fails. So we need to examine why that might be happening. Now I think I could see one problem we have right away. When we call the sensor start method, we actually start capturing data from the network, and that will generate an event, and we add messages to the buffer, and then if the buffer matches, then we generate report packets. But this is all happening in the background, and that takes time. We're not actually waiting here for that to happen. As soon as we call the sensor start method, the thread will immediately move to the next statement, which is the assert statement. And our test is not actually giving any of those background processes time to actually capture data and generate events and create buffer messages and match them. So we need some way to actually get the test to stop, take a pause and wait for things to happen. Now this is always a problematical area with unit tests when you're waiting for something to happen. And in general, when you have a problem creating a unit test, that often points to a problem with your system design. So it's something to think about. Here we're going to actually try to create some small method that will actually just give us a pause after we call our sensor start, and will allow things to happen in the background before we run any asserts. So we can call this method test pause perhaps, and we need to generate that method. In the method here, we're actually going to just use await and then a task delay, and we need to define the delay in milliseconds, so we can maybe take 20,000, that'll give us 20 seconds. That should be plenty of time for us to generate our events and capture our packets and stuff. Now, since this is an await, we need to make this method async, and in our main unit test then we want to wait until the test pause has actually gone through its 20 seconds, so we need to set the method here to an await as well. And that means that our test method cannot be void. It needs to be, first of all, it needs to be an async, and instead of a void return we need to be returning type task, so that Visual Studio understands that this test has asynchronous methods. Now the test pause itself is giving a red line. That's because it's also returning a void, and that's not good. We should be returning a task. So we're waiting here 20 seconds, which is a bit of an overkill, but we just need to get this test to work first, and then we can always return later on and try to get a better solution. Really, you don't want your sensor test taking 20 seconds to run before it comes down and does a cert. So we should be able to run our test again now and see if we're getting any better results. I suspect it will still be failing. Okay, and it still failed. We'll still get the same thing. So I suspect actually that we never call the report packet captured method, and as a result our test fails. So we need to investigate why that's happening. If we start looking, I guess a good place to start is in our sensor class. Right, so here we can see the sensor class, we process the next message and we get the text from that message. And it's only if the text we extract from that message matches our rule, in this case FTP, then we call the report packet captured method. So something's happening here so that we don't call the report packet captured method, and resulting in our test failing. And I suspect we're not matching FTP against the text we extract from our captured packet. Now if we go to the start capture, we can set a breakpoint here just to check that we're actually generating the event that will actually create a message in the buffer, so we can debug our test. And we do actually generate an event. That's good. So what happens then? We come into our post next message, and there you can see the message is not FTP, it's actually system.bytes array. It's a class, a default to string conversion. So the rule will not match, and we will never call the report packet captured method, and of course our test fails. So where can the problem be? Well, it might be here in the get next message method. If we stop the debugging and examine what's happening in get next message, go to the implementation. Well, here we can see we're just taking the next message from the buffer. So the problem isn't here. It must be where we add the message to the message buffer, and that happens on our capture device on packet arrival event. Here we can see we're adding ePacket.data to string. And as I said earlier, I suspect that this is some sort of default to string class text we're getting, where we were hoping to actually extract the text from the payload from the packet. I think this toString method is failing miserably here. We can set a breakpoint here and run our test again. So run the test, and we're generating our event. And if we look at the toString conversion, we've got our raw packet here, raw capture packet. If we do a quick watch on the whole toString ePacket.data, we can see what the value is. Quick watch, and there you can see, yes, there's system bytes. So we're not actually extracting the packet's payload information, so we need to fix that immediately. We're also, if we note here, we're actually doing all the interesting stuff for extracting IP and TCP information after we've actually added the message to the buffer, where we really want that sort of stuff in the message in the buffer. So I think you can see there's quite a bit of cleanup and refactoring we need to do here. So let's look at that next. Okay, so let's look at these problems one by one. The first problem is that we want to actually get our payload text out from our Ethernet packet. So we can start by creating a string message. Let's call that raw message text. And that's going to, here we're doing a byte string conversion. So I'm going to use via the encoding method. We're assuming that the text is UTF-8, and we send into that the Ethernet packet bytes. So that should give us the raw text, but there'll be lots of strange, unusual characters in that, which is quite unreadable, so we want to process it a bit. And we're going to use a regular expression. So our clean message text. We're going to use the regular expression replace, and the input for that will be our raw message text. And now we need to use a regular expression pattern. Regular expressions are a very useful tool for processing text, so it's well worth looking at it. In this case, I have just used Google to find a good pattern to match against printable and unprintable characters. And this will generate our clean message. And now when we're sending in our network event args here, we need to put this information in there. Now, so here we need to add a new string. And while we're here, we saw that we actually wanted to know when we capture the event, capture the packets, so we can put in a public date time and we also saw that we were interested in which data source captured the packets. So let's put that in the mode as well while we do it. And we'll add those two. Captured is equal to captured. Okay, so if we go back to our reference where we're using that, here we return our network information, network args. So we need to add now the clean message text, the date time now, and the sensor ID. We don't have a sensor ID. When we create a new sharp pcap, it should actually have a private read only. Probably will be making this public later on, but we'll just set this to grid. And on our base creation, we set the ID is equal to grid dot new grid, and then we pass that grid to except that we had set that as an int instead of it should be a grid. Okay, so we're now adding all this information to our network event args, and in our sensor we just fetch out the text. So when we add the message, we should add just the payload. Okay, so we add our message here with the actual payload text. So now we can go back to our test and rerun. and our test is green. Now I think we want to change this so that instead of just adding the payload text, we actually want to create a small packet which has all the information we need, including the sensor ID, the arrival time. So we should really be passing all the information that we extracted through to the event and testing for that. But for the moment, we've upgraded our capability. We're starting to test the report process. And in the next video, we will actually look more at the report method, because at the moment our report agent is just a virtual. It's just a substitute. In the next video, we'll actually create a real report agent which generates a report on our captured information. But I think that's enough for this video. So thanks very much for watching, and I'll see you in the next clip.